there's something I've wanted to nitpick about from the very beginning since I started reading your writing. And I've decided I'm not going to nitpick about this until it becomes a problem. And now it has officially become a problem, and you'll see why. You'll see why. So number 11, you did for asymptotes, you did this. You said, okay, the asymptotes occur at plus and minus b over a, where b is the one thing that gets squared in the denominator of the y stuff, and ditto with the x stuff here. And then you said, oh, but yeah, and we did like how we did in class, and it gets shifted like that, right? Where we plug in, instead of x, we say, well, x is actually x plus 1, so we could plug in an x plus 1. Y is actually x plus 3, and so you could either plug in the x plus 3 over here, or bring the 3 over, or you could think about that as a shift down by 3 units. Cool. And then you wrote this. And yeah, you made the x a little bit smaller and made it look like it's up there. But when I look at that, the question is, well, is that this? Are you talking about plus or minus x plus 1 over 2 minus 3? Or is that what it looks like, plus or minus x plus a half minus 3? And up until this point, it hasn't been a problem. And I told myself, I'm not going to nitpick, you know, but now it's a problem, because before, if you were to write something like this, 2/3 x, in context of what we're dealing with, of course, you're talking about 2/3 times x, because pretty much everything we've done up until now has just been like a line, right? So y equals this would be, oh, you're talking about a slope and x, and so it's 2/3 x. But now that we're talking about hyperbolas, now it's ambiguous. If you were to write this 2/3 x, do you mean 2/3x? And so there's 2 ways that you could get around this. If you want to continue to cram everything onto one line, I don't know why anybody would do that. To me, like if I were to write my stuff like that, it's like it hurts my eyes, and I don't get a very good feel of what's going on. But like if you need to cram everything onto one line for whatever reason, that's cool. But from now on, I'm going to say we need parentheses to make it unambiguous, right? Like how I've written it here, like this right here. If you use parentheses, there's no doubt at all at what you mean. And also, right, like if you write this 2/3x and you actually mean 2/3x, we would need parentheses like that. Or you could take up a little bit more space on your paper and make it completely unambiguous. However you want to go about doing it, that's cool. And so I'm not taking any points off for that. I know what you mean by that, and you're right, like that works. It's fine. It's just now my pet peeve actually matters, because there is the possibility of x being in the denominator and so on and so forth. So that's all I'm going to say about that. I'm going to get this out of here right now. And I'm going to leave this up here because we're going to go through this problem right here. We're not going to worry about asymptotes for this one. Okay, now here's another thing that happened. This actually is wrong, and I'm gonna have to like deduct 1/4 of a point or something, because check out what happened. For the asymptotes for number 13, you did the same thing. You said, okay, they occur at plus or minus b over a times x. And b over a gives you 5/4, and so that's your slope. Okay, cool. Then we say, okay, and it was actually the same numbers, right? Like x was an actual x plus 1, so you plug that in right there. And it was a y plus 3, so bring the 3 over, or you can think about it as bringing the whole entire thing down by 3. Cool. And then from there, I think you wrote this right here, which is not correct. You wrote plus or minus 5, blah, 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 blah. The reason this is not correct is we have to think about what this means. If it's plus, then plus 5/4 gets distributed into here, and we have 5/4 x plus 5/4, like I've written right here. And then the minus 3, I went ahead and wrote as quarters. -3 is the same thing as -12 quarters. In which case, this thing reduces down to 5 quarters minus 12 quarters is -7 quarters. And we have +5 quarters x minus 7 quarters. Here, when you distribute the negative in, you get the -5 quarters x, -5 quarters, which then when we bring in the 12 quarters makes it -17 quarters. And so it's not, if you leave it like this, yes, it's true. And that's perfectly good if you want. It's really nice to write it in the form y = mx plus b, because this is what we're, one of the things that we could check right away with
that way, because that's not how the book did it.
And that's cool. That's, you know, I'm just saying, what, like, I'm not a stickler about that. So, but here's the thing, because check out what you drew. Not sure exactly. There's something like this, I think. And we had our asymptotes going like this and like that. And check this out right away. You could look at this and say, wait a second, hold up. If this, what you answered, were correct, if it were in both cases either plus that and minus that, well, this would have the same intercept right here. And we could see that these lines clearly don't have the same y-intercept, right? One of them is -7 quarters. The other one is -17 quarters. And so if my answer were this, we'd say, well, wait a second, no. Plus or minus 5 quarters x minus 7 quarters would both go through -7 quarters like this. And so again, this is perfectly fine and we could keep it like that. But if you want to take that extra step and do this here, it actually helps you out, because then you could look at the thing you've drawn, and not that we need to label those points or anything, but just really quickly by taking these extra couple steps, I could stand back, look at my problem and go, yeah, okay. The one with the positive one has the higher up thing that goes through down here. Yep, that looks good. The one that goes through down here at a different place has the negative slope. And so I could check that, yeah, those guys look good. I think we're good to go. So that's that. Just be careful on that. I'm not going to take off any points for that, because, well, maybe I don't know. I haven't decided. I'm not too concerned about points, really. The idea is you made a mistake, and that's good, because now we can learn from it. It's like, had you not made that mistake now, you might have made it on a quiz, right? And so now we can say, aha, now I know I need to be careful here, because it's not simple. I can't simply go, yeah, do it on one side and then say, oh, it's just plus and minus for both of them. So is that clear? We good?
Yeah.
Okay, cool. All right. So I'm going to get rid of all of this. Now, something I noticed happening in the homework. So what I want to do, I want to go over this one real quick, and I'm going to do it the way that we did it 2 days ago. And then I'm going to do it a slightly different way. In order to show you something here. So the way that we discussed this is, okay, we've gotten we're either given it this way, or we've taken our equation and we've put it into this form. And what we want to do now is graph this thing. Okay, we want to graph this thing. Now, the method that we discussed in class, I didn't make a big fuss about this, but what we're doing here in the way we did it in class is we're going to say, well, this is not what we're working with right now. Like, what I'm about to do is not this thing. We're going to say, this is as though you have this thing, the thing that has not been shifted yet. And if we started with this thing that has not been shifted, right? I'm going to say this a few times to really drive this home. if we started with something that were like this, which we don't have, but if our original thing were like this, then it would be the case that all I would need to do to find the intercepts or the vertices of this thing is to say, well, if I set x equal to 0, if I set x equal to 0, then it would be the case that we would have y squared over 2 squared equals 1, which means that y equals plus or minus 2. In this case that we're not actually dealing with. It would also be the case that if I set y equal to 0, but I don't really need to do that part because I could see that the x has the negative on it. And I know that in the case, which I'm just going to go ahead and write out, but we're not going to worry about. If that were the case, that would make that entire thing drop down to 0 or just go away. And I would be left with negative x squared over 4 squared equals 1. Which means that x is imaginary. And so we could forget about it, right? Because, you know, why? The negative right there, we bring the 4 squared up as a negative. Take a square root of a negative, you get an imaginary number. Okay, so that means it does not go through the x-axis. In this special case, then, my thing that I'm dealing with would look like this. It would go through the y-axis at plus and minus 2. So we have here at plus 2, down here at minus 2, like that. And it would do this type of thing. And it would be the case that we would have 2 over 4 would be, right? 4 over 2, sorry, would be my asymptotes. We would have y equals plus or minus b over ax. B is always a thing that goes with the y, and so that would be 2 over 4. Yeah. Y equals plus or minus 2 over 4x, or y equals plus or minus 1/2 x. And it happens to be, because in this special case we haven't shifted it, then it does this right here. And at this point, I'm not trying to draw this accurately. I'm just going to go ahead and do that right there. Okay, then, so that's starting there. Then we say, all right, but that's not what we have. This is kind of the simpler version of this thing. And so we could take this thing and realize it as a shift. So we shift 1 unit in the x direction to the left, 1 unit left. And then we shift 3 units down. And so what that does, so we're going to shift 1 left. And we will shift 3 down. And then, so then what I do is I just imagine, okay, if I grabbed this object, brought it over 1 and down 3, then the new thing I would end up with would be, okay, so my thing was up here at positive 2 and 0, or at 0 for x and positive 2. I bring it 1 unit left, 3 units down, starting here at 2, 1 unit left would bring me here to -1. 3 units down would bring me here to -1. And so now I'm at the point -1 comma -1, and that is where this thing does this. Right? In fact, I'm going to, just to be clear here, I'm going to label this point like this so that this does not. So in other words, when x is equal to -1, y is equal to -1. The other one then we could realize as the thing which we start at -2, we bring it over 1 unit and down 3 units. And it should also end up at, in the x direction, -1. But then if we were at -2 and we brought it down 3, it should end up at -5. And so that's the point that I'm labeling right there. Okay. You like how my hyperbola goes behind the label? It looks good, huh? Okay, anyway, so that's the thing. And again, another thing we could do if we were so inclined, we could say, well, and also that thing, since we just grabbed this entire picture, that crosshair right there, the crosshairs there at the origin would go over -1 down to, oh, okay, so that would end up here at -1 and -2. And that is where those things would go. So that was the method we talked about in class. Now, what I saw you doing in your homework was this. And so, okay, do you have this? Actually, I'd like to do this. I'd like to keep this entire picture. I'm going to do this right here. What I saw you doing in your homework was this. So in analogy to this right here, right? I saw you do something like this. X equals 0, you underlined it. And then you said, okay, y plus 3 squared over 2 squared equals 1. So then you solve that by getting this right here. Brought the 2 squared up. And then you took a square root and you got plus or minus 2. Right? That's the step I just took. I just took a square root here, took a square root here, and I ended up getting that, which gives us y equals -3 plus or minus 2, which means y equals -3 plus 2 is -1, or y equals -5. And you'll notice what you did here. You found these points. We found these final 2 points, right? Y is equal to -1, right? That's one of them. The other one is y equals -5. That's that point right there. But this is, as you wrote it, under the assumption that x is equal to 0. X is not equal to 0 right here. That's not these points. X is equal to -1. And check this out. You said, oh, when x is equal to 0, you're kind of implying then the entire equation, our original equation, reduces to this, but that's not the case. In fact, what number do I need to plug in here to make this entire thing disappear? In fact, to be clear, what number can I plug into here to make this thing equal to 0?
-1.
-1. And so see the analogy that's happening here. It's like, I think you're reasoning by analogy. You're like, oh, when x equals 0, then that makes that thing go away. Yeah, in our special case, when we pretend that this is before the shift. And so if we're just saying, okay, we're going to take our hard problem here, reduce it down to a simpler problem, then it is simple to say, well, then yes, when x equals 0, then this entire thing reduces down to this right here. And then we have this, and then we end up right here. And that's how we find our y bits right there. Then we could take them and shift them, and that's what happens there. And then we could go through and do whatever. But if you're starting with this thing, it's not 0 for x that you want to plug in to reduce this overall equation down to this. The number we would need to plug in there would be x equals -1. In which case, then yes, if you let x equal -1, then that part of the equation would reduce to 0 because you would plug in a -1. -1 plus 1 is 0. 0 reduces that entire thing to 0. And indeed, then your equation reduces down to this. And so you would find that y is equal to -1 when x is equal to -1, and y is equal to -5 when x is equal to -1. In other words, you get 2 points on the hyperbola, which are x equals -1, y equals -1, and the point x equals -1, y equals -5. And indeed, that's what we get by doing our shifts. And so now, there's a subtle difference here. It's not that we could just plug in 0 and then make that whole thing disappear. So we got to plug in something specific. And so that would be a different method for going about dealing with this, is to ask, what number could I plug in to make that entire thing disappear? Well, if I'm trying to make that entire thing disappear, I'd plug in a -1. So at x equals -1, this thing reduces to that, and I could find my 2 points right there. Or we could say, wait a second, this is a bit tough. We could turn this into a simpler problem, do it this way, and then shift it. And that would give us our vertices and blah, 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 blah. But in both cases now, we don't have these intercepts right here. And that occurs where y is actually equal to 0. Because another thing that I haven't written up here is in your work, you wrote x equals 0 and you did this, and then you did y equals 0, and then you just made that entire thing disappear. But it's not the case that y equals 0 makes that disappear. What number do I need to plug in for y to make that whole thing disappear?
-3.
-3, which is, again, you could think about, oh, that's why this thing shifts down to minus, why the shift in the x direction or in the y direction is a minus when you go plus. But anyway, so, okay. The way I recommend doing it is to pretend it's the simpler case first, then shift it. And then once you have this, Peter, please, buddy, that's really loud. Okay, so I'm going to get rid of this right here, over here. Because now that we have this sketch, we could see, okay, if it's the case that we started with the simple thing and then we shifted it, now I could see that this thing has to go through the x-axis. And I'm going to have to find the x-intercepts. Uh-oh, there's also y-intercepts for this guy. We have intercepts in both cases, it looks like. So what I'm going to need to do is find those intercepts. And this is where we actually plug in x and y equals 0. And so what I'm going to do is, just to recap, start with the simple case where there's no shifts, then do the shifts, and we end up here. And that guides me now. Now I could expect, I'm going to have intercepts here, and I'm going to have intercepts here. So I'm going to need to find everything, really. And so now this is where we're going to say, okay, let's find the y-intercept by setting x equal to 0. Now that I've done that, my original equation reduces to this: y plus 3 quantity squared over 2, minus 0 plus 1 squared is just 1 over 4 squared equals 1. And in this case, I'm just going to go ahead, just to make things simple, I'm going to go ahead and square out those numbers. You don't have to. I don't like to, but I think it's easier to see. So I'm going to rewrite that as a 4. I'm going to write that as a 1/16 like that. And I'm going to write this. Are you following so far?
Yeah.
So I'm going to go ahead and rewrite 1. Since I know what I'm about to do, I'm about to add 1/16 to both sides. I'm going to go ahead and rewrite 1 as 16 over 16. That's just going to make my life easier. Adding 1/16 to both sides gives me 17/16. I'm still left with a y plus 3 squared over 4, like that. Let me know when you're here.
Yeah.
Okay, so now I'm going to multiply both sides by 4. Doing that, or I could just think about that as bringing the 4 up into the numerator over here. 4 on top is 16 on the bottom. That's going to reduce down to 17 over 4. Nice. Y plus 3 squared is that guy. I'm going to take a square root of both sides. 17 is prime, so I don't need to worry about him. The 4, that's going to go down to a 2, so that's nice. Square root of both sides. That's going to be plus or minus root 17 over 2. So write it. Y plus 3 right there. Finally, I get my y by itself by going y equals -3 plus or minus root 17 over 2. And let's see. Root 17 over 2, that's like a 4. It's a bit bigger than a 4. Bit bigger than 4 divided by 2 is a bit bigger than 2, but not quite. Yeah, so here we go. We go to -3. Oh, look at what I did. That right there should have been a -3. So remember how I did that shift, right? I said we take our crosshairs that were at the origin. I brought it over 1 unit and brought it down 3 units. That should end up down here. Those crosshairs should end up at -3. Now it's kind of nice to see that these y-intercepts occur at -3 plus some amount, -3 minus some amount. And so that's cool. That should be the case. Everything should be nice and symmetric like that. And the only question is, did I draw this right? Is this actually a negative number? Or should I have drawn this like that? That's the question I'm trying to answer right now. And so, well, that will be the case. Well, the -3 minus the amount is definitely that guy right there. So -3 minus root 17 over 2 is that. Now my only question is -3 plus 17 over 2, is that bigger than 0, or is it the way I've drawn it actually less than 0? And so what I'm going to do is just basically mathematically ask myself that question. Is -3 plus root 17 over 2, is that less than 0? Well, how about I take that 3 over to the other side and say that's the same question as asking, is root 17 over 2 less than 3? Why did I do that? Well, I'm dealing with an inequality. And if I could get rid of negatives, that would be nice, because I know what happens when I multiply an inequality by negatives, and it's like, yeah, I don't want to do that. I also know I need to get rid of a square root, which means I'm going to have to multiply something. or square both sides. And if I get rid of negatives, that's going to make my life easier. So let's see. Multiplying both sides by 2 gives me that right there. Have you followed so far why I wrote this in the first place and how I got to here?
Yes.
Okay, because I'm trying to figure out, right, is that point drawn in the correct place? Is it indeed below the x-axis? Is it a negative number? Is this a negative number? And so I'm moving it around. Now, finally, I'm just going to square both sides because I have positives. And that should be fine. If I square the left-hand side, I get 17. If I square the right-hand side, I get 36. And I can see, yes, indeed, 17 is less than 36. Therefore, root 17 is less than 6. Therefore, root 17 over 2 is less than 3. Therefore, negative 3 plus root 17 over 2 is that. And so I could say, yes, That is correct. I'm going to go ahead and label that point and say this point right there is -3 plus root 17 over 2. So I feel good about that. I got the other point labeled. Now I don't need to worry about these 2 points. I'm sure that if something starts down here at -1, 1, goes through the y-axis down here, then it's got to go through the x-axis in the positive one. So, I mean, on the positive side, on the right side of the y-axis. So I'm not going to have to do that again, but I'm going to have to find those 2 points, which sucks. But they occur whenever y is equal to 0. So I'm going to have to go back and do that. Can I get rid of all this stuff right here?
Yeah.
All right. So now finally, I'm trying to find x-intercepts. So I set y equal to 0, and I get 0 plus 3 squared over 2 squared minus x plus 1 squared over 4 squared equals 1. And I'm hoping that, because if I know that if I go to take a square root of a negative number, my life's going to be bad. So like if, for instance, this were not there and I were trying to take a square root, I would be in pretty bad shape. So hopefully when I go to take this over to this side, I end up with a negative number. This is the same as 9/4 minus x plus 1 squared over 4 squared equals 1. But I'm going to say instead of 1, I know what I'm about to do. I'm about to take that 9/4 over. So why don't I write 1 as 4/4? So now I'm going to subtract 9/4 from both sides. Are you good up to here?
Yes.
Okay, so I'm going to subtract 9/4 from both sides. That gives me negative x plus 1 quantity squared over 4 squared equals 4/4 minus 9/4 is negative 5/4. Yeah, it is. Okay, and so, oh, nice. All right, now I have a negative and a negative. My life is good. I could deal with this. I'm going to say that's the same as plus and a plus. So I'm just going to forget about it. Forget about those signs altogether. Okay, so how about we multiply both sides by 4 squared? That gives me 5 over 4 times 4 squared. 1 4 cancels, leaving me 1 4 in the numerator. 5 times 4 is, well, I know I'm about to take a square root. It might actually be easier to leave it as 5 times 4. I'm just going to do that actually. 4 times 5. So x plus 1 squared. I don't need to do, if you like to, you just write it as 20 and then just plug along and everything will be fine. So now I'm going to take a square root of both sides. Doing that gives me a plus or minus 2 square root 5. Right, I just pulled out the 2. Yeah, and that's x plus 1. Okay, x plus 1 right there. And so to get x by itself, I'm going to subtract 1. Minus 1 from both sides, plus or minus 2 root 5. And I could see, looking back at my picture, that actually makes sense because it should be symmetric about -1 because my shift was 1 unit to the left. And indeed, that's what I find. I have a -1 plus 2 square root 5. We don't need to do it because we already did the hard work to find that, yeah, that's got to be a positive number. If you wanted to, or if you had done this first, you could say, is -1 plus 2 root 5 bigger than 0? And so is 2 root 5 bigger than 1? Well, is squaring both sides? Well, yeah, I don't need to square both sides. I could see that, yes, 2 times root 5 is bigger than 1. But if you really wanted to be pedantic about it, you could say squaring both sides gives you 4 times 5 bigger than 1. Yes, okay, you're good. So we didn't need to do that. I just like to be complete. It's another way we could have found that point. The other one is -1 minus that amount. And so we get -1 minus 2√5 is right there. And I'm not writing it as a point either. You know, I've drawn a dot here on the axis and I put an arrow saying, hey, that occurs right there. There's no ambiguity there. I know what you're talking about. If you really want to, you could do this, comma 0, but that's unnecessary. We don't need to do that. Is this making sense?
Yes.
Cool. And I know we've been blowing through this stuff, and it's hard to keep in mind that we're not simply just like in one case, yeah, we're simply setting x equal to 0 to find out where the vertices are, but that's assuming that we're talking about the special case that before it's been shifted. And but in this context, plugging in a 0, like an actual 0 to find out where it actually goes through one of the axes, it's not as simple as saying, oh, well, if y is equal to 0, it makes that whole thing disappear. Well, no, it doesn't. It has to be -3 to make that whole thing disappear. And so that's another method you could use. You could say, well, let's just find the vertices and all that. But then, I don't know, to me, that's harder to say, well, okay, in order to make that disappear, I would need to plug in a -1. And then to find, okay, well, then we have our two vertices at -1 and -1, and then -1 and -0.5. And then, I don't know, it just seems rough. The final thing to do would be to find the asymptotes. And so to do that, we again pretend that this is the case, that it's before it's been shifted. And we're back to our original picture up here at 2 and 2 and -2. And we say, well, in this case, if it had not been shifted, then these asymptotes would occur where y equals plus or minus, the plus one's the up one, the minus one is the minus one, b over ax. B, in this case, B always paired, the way we've done it, it's not the way your book does it, but the way we've done it is that B is always the one that's paired with the y. And so that's going to reduce down to plus or minus 2 over a is 4x. And so that means y equals plus or minus 1/2 x. Then we finally say, aha, but wait a minute. We've taken this thing and we've shifted it 1 unit to the left, 3 units down. And so we could do that by just straight up plugging in x plus 1 in for x and y plus 3 in for y. Or we could say, well, we could shift the x by going plus or minus 1/2 parentheses x plus 1. That takes both of those lines and shifts them 1 unit to the left. Then we could say we need to shift them 3 units down. And so we finally say, okay, that's y equals plus or minus 1/2 x plus 1 minus 3. Or we could have said, well, that's the same thing as shifting y, like as one thing. And so we would have a y plus 3 on the right left-hand side. Well, it's weird to write a line with a y plus 3 on the left-hand side. And so I kind of like this right here. And if we wanted to be really cool, then we could put this into slope intercept form and double check that, yeah, our thing does the thing and blah, 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 and make sure everything's going through the correct places. But this is sufficient right there. It would be cool to label these things though. Although, I mean, it's all right. We can just leave it like that and say, make sure that we know that these are the asymptotes, are those two bad boys right there. Okay.
Okay.
Okay, cool. So that's what we're doing. That's the idea with this. You'll notice it's pretty much the same thing that we did with ellipses, the same reasoning, really, and even the same method, right? Draw the unshifted thing, shift the thing, see, does it go through axes? Yeah, okay, well, we're gonna have to plug in zeros. And plugging in the zeros turns your original equation into, well, a nightmare, but it's all right. You end up getting something out of it. And the only new thing really is the asymptotes. The asymptotes are always, before you shift it, they always go through here and here. So there's no there's no y-intercept part. And then you just take it and shift it the way we've been shifting functions. And there you go. So what I would like for you to do is redo 15 from the top. Just go through it. I know you've already completed the square and got it into the form. Do it again. It's great practice. Just go ahead from the top, do it again. And do everything, right? We want to label, basically just do what we did here for 11, but do it with 15. So that's part of your homework for this weekend. Can I erase all this stuff?
Yep.
Any questions?
No.
Did that clear up some stuff?
Yes.
Cool. Good. All right. That's my goal. All right. Now, number 23. So, number 23, it's all about the asymptotes. So I would also like for you to do this one over again. And I said, so first off, you did not follow the instructions in the book. It said graph a pair of conjugate hyperbolas on the same coordinate axes. You did two different pictures. And it also said, what do you observe? You didn't tell me anything that you observed. Unless it got cut off at the bottom of the page, I didn't see anything. You just graphed it. What I'm looking for. And this is a good thing in general. And I said, I think the way I worded it was, imagine that A and B are obviously different numbers. And then what you did is you did a special case. So we have both x squared over a squared minus y squared over b squared equals 1. And we have y squared over a squared minus x squared over b squared equals 1. And I think you use like 2 and 5, which is cool. It's not, I'm not nitpicking that you chose a special case and you drew a special case. In fact, that's kind of what the question says. It says graph a pair of conjugate hyperbolas. And so that's fine. What you did was fine. The problem is that this really, what the question is asking is really about the asymptotes. Now, you could still use 2 and 5 when you go to do this. What I would do in this question is I'm just going to imagine that we'll say that A is bigger than B. No, yeah, we'll just assume A is bigger than B. And this thing then, I'm just gonna do one of these and leave this to you here. I'm going to say, okay, if this were the thing, and I'm going to assume that A is bigger than B. And in my head, I'm going to assume it's about 2 or 3 times bigger. You'll see what I mean by this here in a second. So, okay, just going to assume A is bigger than B. So let's just take this guy right here and let's graph it. All right. First off, I could see that the y is the part that has the negative. And so he ain't going through the y-axis. If I try to cover that guy up and solve for that, he's not going through the y-axis. So that is the case. When I plug in a y, I'm sorry, when I plug in a 0 for y, it makes that guy disappear, which means that x is equal to plus or minus a squared. We could see that. To be explicit, what I'm doing in my head is saying, well, if y is actually equal to 0, then my equation reduces down to this guy right here, which, yeah, we get this right here, which means that x is equal to plus or minus a. And so, all right, I said we're assuming a is bigger than b. So I'm going to draw this kind of big out here. We have plus a, and we have here, say minus a. And it's a hyperbola. So it's going to go off in that direction like this. But the key here is the asymptotes. So what I'm going to do is just imagine that A is bigger than B. So I'm going to imagine that B is maybe this big right here. And so my asymptotes, so that's going to look terrible. I'm going to make it a little bit bigger. I'm just going to assume that B is right about here. Okay. And so now when I'm getting my asymptotes, I'm going to think, well, the asymptotes occur at y equals b over ax. And so what we're talking about is a rise and a run, right, for the asymptote. And in this case, when it's the positive one, it goes over by a and up by b. And so it looks something like this. Comes back that way. And then when it's y equals negative b over ax, that's same thing. The run is still a, but now the b is a fall. And so where I was here, I'm going to come down here to say negative b. And if you were doing this with actual numbers like 2 and 5 or 2 and 3 or whatever, actual obviously different numbers, you'd end up with the same picture. But the point here, the crux of all of this depends on the asymptotes. And so I've done half the problem. Oh, actually, I'm not quite done because I haven't graphed this thing yet. It goes like this and like that. This one goes like this and like that. And so I've done what I can to keep this as general as possible. It's not necessary to do this, to say this. It's just going to help you when you do part 2 here. And so I would like to also see this one. So you got to do 15 from the top. 23, if you feel more comfortable with using actual numbers and plugging in actual numbers and finding slopes and all that stuff, cool, go for it. It would be really cool if you try to keep it as general as possible, because that's really, we want to do that as much as we can. And we don't need to make one obviously bigger than the other. I'm just saying it's going to help you to get to the final conclusion when they ask, what do you observe? If you've done it this way, what you observe will be pretty obvious. And if you try to actually use the links that you've done, if you want to use graph paper and whatever, that's cool too. But it's really slick if you use A's and B's when you're given A's and B's instead of plugging something in. Again, that's not necessary. You could do that with any of them that you want. It's just slick. And so when you go, and this is the key here, like this is why they say this, to graph it on the same coordinate axes. So you're going to complete that part. You're going to get up to here, either using A's and B's or using 2 and 5 or whatever. And make sure you do the asymptotes and then do the same thing on the same axes for this guy. And then the question might make some more sense when they say, what do you observe? And so have at it. I would like to see that. And I don't want to give it away. I want to see what you come up with for that. And honestly, even if you don't observe it, if you're looking at it, you're like, I don't know, one's going one way and the other's going the other, Justin, like, that's cool. State that and cool. We'll move on from there. But you might notice something interesting. So, okay. That's all we have for homework and stuff like that. Are we ready to move on?
Yeah.
Okay, so we are not going to do 10.5. 10.5 is parabolas. And as far as I'm concerned, we have done parabolas into the ground. The only difference is that they're in 10.5, they're going to present parabolas as a conic section. And with basically their classical definition, which is not the way that we've defined it, which is ax squared plus bx plus c. They say that a parabola is the set of points that, so given a line and a point, and I've gone ahead and drawn it like this. Honestly, we could have drawn it in any way. I could have drawn it in this direction. I could have drawn it slanted, any line and any point. Where am I going to put that point? How about here? There you go. Anywhere. Given a line and a point, then we define a parabola as the set of points that are equidistant from the line and the point. What does that mean? Let's think about it. Equidistant from the, well, this is an easy one, right? There's a point right here that is halfway between these two things, so that the distance, I'm going to call it D1, from some point to the given point is the same as the distance from the line to that point. And if we take all such points, you end up with a parabola. Again, to be clear here, we're saying that this distance from here to here is equal to this distance from here to here. So this is another way of presenting a parabola. And you could show that just starting with this definition and then bringing in some kind of axes, an x-axis and a y-axis, you could show that these things end up with this formula right there. We're not going to do that there. And then there's another thing that, again, we're not going to talk about. They call this the focus. Go figure, right? Like that's kind of what we've been, that's the idea. Oh, and this is the set of points where D1 is equal to D2. This focus has certain properties. Given a parabola, you could find its focus. There's a few special ways of writing that, another way of writing a parabola that is not in this form. But really, you're never going to see that outside of this chapter and maybe a couple other chapters. The thing, though, is that just like with ellipses and with hyperbolas and with circles, those things weren't functions because they didn't pass the vertical line test. In this case, if it's oriented this way and you end up with a y equals some x squared stuff, then you end up with a function. But it's possible to end up with a parabola that does something like this, a sideways parabola. And in that case, it, as written, is not a function. And you're going to need to know, or you're going to need to be able to identify and sketch a parabola that basically has the roles of x and y swapped. And that's the only thing here. So real quick, let's do something like that. So we're not going, again, we are not going to deal with the focus. We're not going to think about it in this term. Oh, and by the way, this line right here is called the directrix. And if you're going to go take a standardized test or something like that, you would want to review the formula for a focus and a directrix, given all this stuff. It's all in chapter 10.5. It's not going to help us out very much. And you're never going to see it again, ever. So we're not going to waste time on it. However, what you are going to need to do is be able to identify when a parabola is a horizontal parabola. And let's just start like this. Let's say we have something like this. Let's say we have B equals, oh, I had one I wanted to do. Let's do it this way. Oops, not X. I didn't write this down. We're going to go minus, let's go 8x plus 1 right there. No, 8x, get out of here, man. 8a, okay. Now, that's a parabola, and we could think about the a's as being my x-axis, and we could think of my b's as being a y-axis. And we could say, well, let's graph this guy. Let's see what he looks like if we have an a-axis and a b-axis. And I'm going to cut right to the chase and say, well, hold up. Why don't I complete the square here? Because then I think it's one of the most straightforward ways of dealing with these things. Is that right? Check me on that. Am I completing the square correctly on this?
It looks right to me.
Right? Okay, so I'm gonna say that's the same thing as a minus 4 squared minus 16 is 1. And so altogether now we get that B is equal to A minus 4 squared minus 15. And so I could say, okay, and I really don't want to get crazy with this. I just want to say, okay, this is a shift 4 units to the right. And so we end up here at A equals, I'm going to not go that far, A equals 4, and then down to minus 15. And I'm pretty sure this thing's got to go through over that way. It's got to do something like that and then come up this way. And if I wanted to, which is not the point right now, I could find these 2 points, one here and one here. Okay, yeah, nothing new. We just, instead of X's and Y's, we're calling them A's and B's. Now, but what if we did have X and Y's, and what if it wasn't X squared? Oh no, what if in the end we actually had, if the B axis was the x-axis? Oh no. And what if the a-axis was the y-axis? Oh no. Well, we could, yes, I could just label this axis as y, and I could label this axis as x. And my original equation, I guess, would be x equals y minus 4 squared minus 15. Right, that wasn't my original equation. That was my derived equation. My original equation would have been something like x equals y squared minus 8y plus 1. What if we were in that scenario? Well, again, like I said, we could just pretend that the B here is x. That's my outputs. And we could pretend that my A was my y's. And so we're saying, well, yeah, we're just relabeling it. Who cares? They're just symbols, and we'll just pretend that y is this one and that x is this one. But sometimes you'll have multiple things that you'll want to graph or whatever, and they'll all show up on one axis here. And we don't want our y like this. Or for whatever reason, you might really want your y to be the up-down thing. So what do we do? Well, what I think, like, so for instance, we're in this situation where we have something like this. We're able to get it into the form x equals y, blah, 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 blah. And we want to graph this on the canonical XY axis, where the X is the horizontal and the Y is the vertical. What I like to do is just pretend for a second, just like we did here. Say, well, you have an input-output relationship. And if this were something like this, I would go through and say, yeah, it's like this. And so we have my A inputs and my B outputs, and you would have that. But oh, lo and behold, what have we done? Well, we just flipped the roles of inputs and outputs here. And so I'm going to give myself some space. I want to rewrite this up here above this and say, this is the same thing as y minus 4 quantity squared minus 15. And so in that case, this is what we do. I'm going to get rid of all this stuff here and say, okay, we have this picture and we need to flip the roles of X's and Y's. And so what I'm going to do is draw my X and my Y axis like we're used to and say, well, hold up, this is just this flipped around. This is Y and this is X. And what I think the easiest place to start with is this vertex. This tells me right here, this is where X is equal to 4 and where Y is equal to minus 15. So I'm going to say, well, let's find that over here. X is equal to, oh shoot, you see what I did? I did it backwards because I'm so used to that. This, I'm sorry, over here, this is the Y axis where Y is equal to positive 4 and X is equal to negative 15. So I've graphed it in the way that I'm used to graphing it. And now I could just say, well, we're just flipping the roles. And so now X is equal to minus 15. So X comes down here to minus 15. And Y is up at positive 4. So it's right here, like this. And yeah, the thing opens up, right? These things go up towards the positive x-axis. This is the positive x-axis. So it must go from the point up towards the positive x-axis like this. And there's your thing. Boom, you're done. Had you found these points, we'll call this root 1 and we'll call this root 2. You would just say, oh yeah, root 1 would be, well, the positive one is, oh no, the negative one is root 1. So that guy, and again, you see what I'm doing, right? I'm just saying, well, this root occurs at the negative y value. So the negative y value would be down here. We'll call him root 1. This is the positive y value. And yes, indeed, he occurs above the positive 4 in the y direction. And so again, that guy's going to have to go right here. And we'd have root 2 right there. And so that's the idea. I'm not sure in the home, I'm going to modify the homework. I don't think these actually show up in the homework I want to assign, but you're going to have, like, you're probably going to encounter this. And it's really good to be able to basically flip this stuff around in your mind. And when we do exponentials and logarithms, well, it's going to be a lot different from this, but we're going to be doing this idea of swapping my inputs and outputs. That will be, it'll be helpful. And so in this case, with the parabola, we have the point that we really care about, the point that we can always find by completing the square. And so that's what we do. We find that point, graph it as though it were the easy thing to graph, and then say, but wait a second, we need to have this the other way around. So find where it takes that point and then use your brain, right? Like, well, this is going in that direction, so it's got to go in this direction. This one was the negative y, so he has to come down here to the negative y. Does that make sense? Questions about that?
I think that makes sense.
Yeah, there's not much to it. In fact, I'm not really giving you any work about this. It's just, it's good. You're going to encounter these guys. And it's good to be able to graph them, even if they are not functions as written like that. We need to know that anytime you have y squareds, but you don't have any x squareds in one of those general types of equations, you still end up with a parabola. It just happens to be a parabola that's opening the weird way. So there's that. All right. We are almost done. The only thing, I am going to give you some homework for tonight. You have those 2 redo problems to do, number 15 and 23. But I'm going to give you stuff from 10.6. And it's basically just identifying when or given. So can I get rid of all this stuff?
Yep.
Okay. So given something like this, x squared plus by squared plus. Notice this is going to be different from how we've done it before, because we're not going to do the mixed ones. You're not going to be responsible for figuring out what the xy, right? The x times y thing, like that is a huge wrench in the gears, and we're not going to worry about that. What is going to be important is, given something like this, figuring out whether it's a circle, an ellipse, a hyperbola, or a parabola. Of course, it could be a line, like if the a and the b are 0, it could be a line, okay? But it's obvious, like we're given something like this. And so, for instance, given this thing right here, minus x squared minus y squared minus 3x plus 2y plus 4 equals 0. We want to classify this, which means figure out whether it's a parabola, a circle, a hyperbola, or an ellipse. So basically we're classifying as a conic section. Another possibility, it could be none of them. For instance, if we had something, let's say we took this thing and we manipulated it and and we ended up with something like this. Let's say we ended up with that. Oops, need a squared right there. It would turn out that this is not a conic section. I think in your book, when this happens, they say does not exist. It exists, just not in the real plane. It would have to involve complex numbers, but blah, 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 blah. That's not what we're talking about. This is neither a circle, a ellipse, a parabola, a hyperbola, or a line, whatever. Like, it's none of these things. Why? Well, this doesn't have any of the form. One of the things is this, we put it into this form and we can't identify it as any of them because there's 2 minuses, right? Like if it were a plus and a minus or a minus and a plus, we'd say, oh, that's a hyperbola. If it were a plus and a plus, we'd say, oh, that's an ellipse. But in this case, we can't even find an intersection, right? You have a negative something squared equal to 1. Another thing we could do is we get it down in this form and we say, well, why don't I multiply both sides by -1? That'll get rid of those negatives. And so we do that. And we say, okay, let's do that. And we get x plus 1 squared over 3 squared plus. And we're like, yeah, I'm in good shape now. Now I recognize this. I have this, I have a plus, and so it must be an ellipse, right? And then we look over here and we get, well, that's a -1. This thing's supposed to be equal to +1. And if you're not seeing that, well, just imagine that you went to solve one of these, right? We plug in a -1 for x, and it makes that thing disappear. And then, you have a -1 over here. You go and try to solve that. You would have y plus 2 squared equals -√5 squared, because the -1 would make that negative. And you take a square root and you would get plus or minus, you're taking the square root of a negative number. That's not going to work. Ditto with the other one. You're not going to be able to solve for x. And so there is the possibility that you go to classify one of these guys and it's not a conic section. And so you could answer not a conic section, does not exist, or something like that, right? But that's, I think your book says does not exist, which kind of irks me. It's not that it doesn't exist, it's that it's not a conic section. So does that make sense what I'm saying here?
Yeah.
Okay. So let's do this one. Let's classify this as a conic section. We're going to say, okay, we want to take this thing, and right now it's not obvious what I want to do. Well, don't do that, buddy. Oh, buddy. He smacked it. Come here, buddy. Okay. You're okay. Yeah. You're okay. We got a new couch, and he's been slamming his face into the pillows and stuff, and he just went and slammed his face into like the hard part of the couch.
Oh.
It's like the couch betrayed me. Okay, so real quick, let's suppose that this were not this. Let's change it a little bit. This is one I want to do, but I want to get over one more case here. Let's say that this were exactly this, only minus y squared 3x plus 2y. So everything's the same except for that x squared right there. I could stop right here and say that's a parabola. How do I know? Well, look, you could get that x over to one side. You won't be, the x has no squared term, so it can't be a circle. The x has no squared term, so it can't be a hyperbola. It can't be an ellipse. The only thing that could be left is parabola or a line, but a line really isn't a conic section, and you're not going to have those. But it's like, well, yeah, I could see this, right? I could get that x over to here, get them all by himself, and then you'll have, that's obviously a parabola, right? Y squared, y, and nothing, right? And so don't let that trip you up. You're like, oh, but parabolas have to be x squared, and we just talked about that, right? If one of the variables is squared and the other one is not, that is a parabola. It might be sideways, but it's still a parabola. So, okay. So, but this is not one of those cases. I can't just look at this and say, yeah, it's a parabola, because, well, we have two squared terms. So what I'm going to do is say, well, looks like I'm going to have to put this thing into the form, right? To try to get it as x minus h squared over some number squared plus or minus, and these we don't know, they could be pluses or minuses, and then into y minus k squared over b squared equals 1. And if we go and do that, and we find, oh, these happen to be the same number, sorry, if they're both pluses and they happen to be the same number, we'd say that's a circle for a couple different reasons, right? We could multiply through and get it all equal to one number up over here. Or you could think about it as an ellipse, which has been stretched by the same distance in both the x direction and the y direction, in which case, well, that's just a circle. So be careful with circles. So moving on, we want to take this thing and put it into this form because I don't see an obvious parabola. So we're going to complete the square twice. I'm going to get the x's together with a minus x squared minus 3x. I'm going to get my y's together with a minus y squared plus 2y. I'm going to bring my plus 4 over here equal to 0, just like that. Okay, now let's actually start doing some work. Looks like I have a -1 in front of the x. Let's factor him out. -1 up front makes this guy positive 3x. Same thing right here. We have a negative 1 in front of the y. So I'm going to factor him out and just write him like that. Y squared minus 2y. So I flip the sign. Parentheses are my best friend in this case. So do you believe it up to here? Are we still good? Can you check me on that?
Looks good to me.
Okay. So now I'm going to take half of this number, square it, add it and subtract it. So that's 3/2 squared minus 3/2 squared. Half of, oh, that's nice. Half of 2 is 1. So I'm going to add 1 squared minus 1 squared. Too easy. Okay, now let's actually complete the square. This is going to be an x plus 3/2. Quantity squared. Now I'm going to go ahead and square this out. Why not? How about minus 3/2 squared is the same as 9/4 right there. Minus right here. Okay. Y minus 1 right here. So y minus 1 squared. And then minus 1 squared is just minus 1. Okay, easy. 4 equals 0. Okay, now here's the really tricky part. I got to distribute that negative back into these guys. And so we have a minus x plus 3/2 squared. A minus minus is a plus. Minus comes back in to give me a minus y minus 1 squared, but a minus minus is a plus. Then we have plus 4 equals 0. Buddy, you're okay. Hey, so, all right, now what I could do is say, well, there's a few things I could do here. I could go about this a bunch of different ways. And all I'm trying to do is classify this guy. And so really, I don't need to find an exact number of what all this stuff is. But just to be complete, I'm going to, like, but what I'm, as I look at this, what I imagine is this, like, well, I need to get these guys by themselves. So if I keep those here and take all of these, oh, these are 3 positive numbers. Add them together, that'll be 1 positive number. I'll bring him over, it'll be a negative number, and then I'll have a negative, that'll be negative, that'll be negative, and so I should end up with positive, right? Because if everything is negative all the way through, I could just multiply through by -1 and everybody will be positive. So I could stop right here and classify it, but I want to be, I want to be a little bit better here. I'm going to go ahead and say 1 plus 4 is plus 5. And then I'm going to say, let's get him over here, the plus 9/4. I'm going to go ahead and do that over here. I'm just trying to save space. I would be doing this one line below another line, but okay. So 5, that should be 20/4 is 5 plus 9/4. 20 divided by 4 is 5. Yes, okay. Plus 9/4, so that gives me 29/4. There we go. And so all together now we have a plus 29/4 right there. So I'm just going to erase that and put in 29/4 plus 29/4. Okay, so all I did is I just absorbed all those constants together and put it all at one, or condensed all of them together, whatever. So on the left-hand side, I have minus x 3/2 squared minus y minus 1 squared equals, taking that positive 29/4 over to the other side gives me a negative 29/4. And we're like, oh no, it's negatives over here. Yeah, but it's a negative over here. So that's fine, because I could take that, multiply everybody through by -1 to turn this into x plus 3/2 quantity squared plus y minus 1 squared equals plus 29 quarters. The only time you need to panic when you see two negatives in front of here is if this is positive. But if everything's negative, you're good to go. You go ahead and just multiply everybody through by -1, and you got that guy right there. And what is that? Is that a parabola, an ellipse, a circle, or a hyperbola?
Oh boy.
Well, first off, is it a hyperbola?
No.
No. Is it a parabola? You should just say no, obviously not. The only way you could have a parabola is if you have one variable that's not squared. Right? The only way to have a parabola is if you have y equals ax squared plus bx plus c, or you have x equals ay squared plus by plus c, right? And so, long story short, the only way to have a parabola is to have one of your xy variables without it being squared. So
it's a circle.
It is a circle. How did you know it wasn't an ellipse? Because it actually is an ellipse. It's just a special case of an ellipse, which happens to be a circle. So
wait, aren't all circles ellipses though?
Exactly. All circles are ellipses, but not all ellipses are circles, right? So let's see this real quick, because I can rewrite this as x plus, you've got to give me a second, buddy. X plus that 1, y minus 1. I could go ahead and divide both sides by 29 quarters. And then it's like, well, I need to write that as something squared. And so I go ahead and write that as something squared. And so if you're not using your brain as you're doing this, right? And you say, well, I'm given something like this, I'm going to put it into that form like this. And you just go through and plug through and do it, right? You see how I did this, right? I just divided both sides by 29 quarters. Did you follow me?
Yeah.
Okay. So you're not using your brain. You're just saying, I don't care what, I'm just going to take this thing and get it into this form. And you do that. And you go, oh, it's an ellipse. This is a special kind of ellipse. It's an ellipse that's been stretched by the same amount in the x direction and the same amount in the y direction, which is a circle. So a circle is a special case of an ellipse. And it just happens to be that both of the stretching is exactly the same. And what do you know? The amount that it's stretched is exactly to its radius. And so, yes, this is a circle. And the only time that's not going to be the case is when the a and the b terms are different numbers. In this case, they're the exact same number. It's -1 in front of both of them. And so, but don't look at this. Please don't just look at those and go, oh, it's the same, right? It's a circle. Well, maybe, or it might have been the case that you go to complete the square and you end up with a minus and a minus and then a positive over here. So you can't just assume, and this is the thing about it, you can't just memorize a list of things and say, okay, well, if there's, well, you can with a parabola. It's like, if there's only one squared term that shows up, that thing's a parabola. But then with the other stuff, you know, you could say, well, if they're the same, then it's a circle. Well, unless it comes out to be like a positive, and then a negative, then in which case it doesn't exist. Long story short, you're going to have to go through this stuff to ensure that after completing the square, you don't end up with junk. Because it might be the case that you end up with, you know, something squared plus something squared equals a negative number, in which case that's not a conic section. So I think that's about it. Any questions?
I don't think I have questions
Okay.
yet.
Some of them, and so then the last, so that's part of the homework. They give you some stuff like this and say, identify it, right? This is, so tell which conic is defined by each equation. Some of them they give to you like this. Some of them they just give it to you in the obvious form, and you're like, well, that's a hyperbola. It's right there, and that's all you got to do. It's really straightforward, except for like this, you can't just assume, oh, it's the same sign, so it's a circle. Well, maybe, hopefully, because hopefully the thing that you end up with over here is a negative number, in which case, you know, or you. So, okay. Then the last thing you're going to do for your homework is they give you a graph. They're going to give you a graph of a circle, graph of an ellipse, and the graph of a hyperbola, and you have to find the equation. And so you've done that with circles and with ellipses before. The hyperbola, they give you the asymptotes, and they're drawn exactly. So you could find the rise over the run. If you know the rise over the run, you should be able to reconstruct everything that you've done. So here's the homework. Oh, I almost forgot. You did not do problem number 22 in the homework.
Oops.
Oops. And that one is basically what the homework I'm giving you tonight is. If you could do that one, the one from tonight is pretty much the same thing. You just have to find the slopes. So I guess you can make that up too. So makeup first up. Make up numbers 15, 22, and 23 from previous homework. Then we're just going to do 10-6. And these are, I'm telling you, some of them are so you just look at it and go, hyperbola, and that's it. And so it's not very many either. So chapter 10, section 6. Page 462. So where is that? Okay. So 1 through 9 odd. 1 through 9 odd. Then we're not doing that one. We're not doing that one. 11. 15. 17. So that's 5, 6, 7, 8 problems. And then 9, 10, 11. But you got 15, right? It's just a little bit extra stuff, you know, like 22 is basically the same as number 17 from this homework. It's just they give it to you in words here. Here they give it to you as a graph. And one thing about 17, I want to say, when I was looking at this, I was like, wait, what? It's hard to see, or if you're just glancing at it, the x-axis is at the very bottom. Like I missed it completely. It's a little square, and the picture's right here, and they give you this stuff right here. And I missed it completely. That's the x-axis is at the very bottom. So then you could count where these points are by all that. It's a grid and all that stuff. You can find it. But 22 is the same question as this. They give you 1 point and then they just tell you what these slopes are. Here, you're going to have to figure that out. In 23, we talked about that. Graph it on the same thing and tell me what you observe.